Hello there, everyone. Excuse me. KP the Math G. I've been trying to clear my throat for the last 10 minutes. Alright, well, anyway, I hope everybody's having a really great day today. I really am grateful for this opportunity to be able to do calculus with you and for you. To help you out, to help you become better. I know I've become better at this, believe me. It makes me a stronger calculus. Well, I'm still a student of the profession. We never quit being students, even though we become teachers. Anyway, we have a 2007 free response question number 6. Where we have a given f at x equals k is a constant, times the square root of x minus ln of x for x greater than 0. K, well, I already did, but k is a constant. This is actually part C of this 2007 free response question. It says for a certain value of k, we already know k is here, the graph of f has a point of inflection, that's a point of inflection, on the x-axis. Find this value of k. Now, let's just quickly review what a point of inflection really is. Okay? Concavity changes from either concave down to concave up, or from concave up to concave down. Alright, so we have the xy axis. Okay, and if there's a point of inflection on, say, some point out here, alright, then somewhere this graph is probably doing something like this, maybe. Alright, and then there's the point of inflection right there, and then it's doing something like that, maybe. This is concave down to the left of the point and concave up to the right. That doesn't really matter. There's just a point of inflection right here. Now remember, if this is a function of f, alright, this is whatever x is, alright, f at x is equal to 0. Right? I mean, the y value. That's the f at x is considered the y value. The y value is 0. So we know that f at x is 0. What else do we know when we consider that this is called a point of inflection? What should we be looking for in terms of a function of f when we say point of inflection? What do we need to find? Yeah, that's right, the second derivative. So I already have the first and second derivative. Instead of coming up with the derivatives, I already have the derivatives for you. And really and truly, all we need is the second derivative. So we're going to do just that. And we got to realize that point of inflection is not the first. The first derivative, what are you looking for? Increasing or decreasing? Max, mins, point, critical point, as in the last problem. All of those first derivatives. Is the graph, does it have a max or a min? You could do the second derivative because you're looking at concavity. If something is concave down, you have a max. If something is concave up, you have a min. As simple as that. I mean, you just got to think about stuff like that. That would be the second derivative for that. And point of inflection. If there is a point of inflection, then it does say that it has a point of inflection. Alright, so I'm going to say here's f right here. We need that. Alright, we also need to know what f at x is as well. Alright, I'm not saying f at x, f double prime at x. And I have found that. It's negative 1/4 rather, kx rather, sorry, kx to the negative 3/2 plus 1 over x squared, or x to the negative 2. And I'm going to leave it as x to the negative 2. It just makes it simpler to look at that way. Now, okay, two things we know. The fact that we look at these two right here. If we have this point of inflection on the x-axis, that means that y, or f at x, is equal to 0. If we have a point of inflection at all, then we know that f double prime of x is also equal to 0. Now, I looked at both of these and got to thinking, well, how do you know f at x is equal to 0? It says, oh, it's on the x-axis, okay. And f at x really is y, okay? Y is equal to 0. X could be any number. And so what we're looking for, we want to find this value of k. Find this value of k. Alright, well, let's do this. I'm going to start with f double prime. Okay, there's several ways to work this problem. Some people set both of these equal to 0 and solve for k, and that's alright too, but I'm going to do it this way, kind of the old-fashioned. And you could actually solve for x and then plug that value of x into the x's here, and you will find that that's the old-fashioned way of doing it. That's actually the conventional way, if you will, of doing it. But I'm actually going to solve for k here. So if I let f double prime at x equal to 0, I'm going to say negative 1/4 x, kx to the negative 3/2 plus x to the negative 2. I'm going to set that equal to 0. If you need black, if black looks better than red, sometimes red is just kind of too red, huh? Okay. Now, one thing I can do is I can bring one of these over here, and since this is already negative, I can do this. I can say, well, if I bring this over here, 1/4 kx to the negative 3/2, all right, plus 1/4 kx to the negative 3/2. Alright, what we have here is now x to the negative 2 is equal to 1/4 kx to the negative 3/2. Alright, that's where we are on that. Yes. And then what I want to do is I want to rewrite this as I'm going to get rid of the negative exponent, and I'm actually going to set up a proportion when I do. So I have 1 over x squared. Remember, you bring this down. This is in the numerator, so bring it down in the denominator. It makes the exponent positive. We should know that at this level. All right. The 4 is already in the denominator. The k is actually in the numerator. I can bring this down into the denominator like that. So I have k up here over 4 x to the positive 3/2. Alright, just kind of, yeah. I like to set it up like this. I like to kind of set it up as a proportion, and it's easy to solve like this, doing it this way. Alright, now I'm going to multiply both sides to get rid of this to solve for k. I'm going to multiply both sides by 4x to the 3/2 times 4x to the 3/2. So now we have 4x to the 3/2 over x squared is equal to k. Now that is k, but let's kind of clean it up a little bit. I want to see, let's get this in terms of halves. 2 is equal to 4 halves, isn't it? Right? So 4 over 2 is 2. Alright, so I'm going to make this 4 halves. Alright. And when I subtract these exponents, 4 minus 3 is 1. So 1 half, but it goes down here because 4 is bigger than 3. Alright, so this is 4 over x to the 1 half, which is k, or you can say that's equal to 4 over the square root of x. So k is equal to that. Now that I know that k is equal to this, we're going to flip the board over. I'm going to rewrite this one, and then now that I've got k, that's what I wanted to do. Now I don't have yet k in terms of f yet. I do have it in terms of f double prime, what I got from here, but this is not the final answer. So don't stop there just because you found that value of k. We got to go a little bit further. We got to go into this. We cannot ignore that f at x is equal to 0 as well. So in place of this k, I'm going to put this right here, and we're going to see what happens here. And we're going to set this equal to 0 right here. Alright, so let's flip the board over. K times square root of x minus ln of x, okay? Alright, so f at x is equal to k square root of x minus ln of x. Double checking, let me make sure. Yeah, k square root of x minus ln of x. Alright. You just can't ignore this. You can't say, okay, I already got k as the answer. You're not done yet, because you've got to remember this is on the x-axis. This point of inflection could be anywhere, but we've got it on the x-axis, which means that f at x is equal to 0. So we cannot ignore that. Alright, so here we go. Let's do this. Now remember, k is equal to 4 over the square root of x. Let's put that down, because we're going to need it later. Okay? Now I'm going to take this and set it equal to 0. K times the square root of x minus ln of x is equal to 0. And then I'm going to substitute in place of k 4 over the square root of x times the square root of x. Now remember, this is all over 1 minus ln of x is equal to 0. Look what happens to the square root of x. And we said that in the beginning that x is greater than 0, so we're okay if we divide these two out. So that's good. Not equal to 0, greater than 0. Alright? So now what we have is 4 minus ln of x is equal to 0. And now I can just bring this over here. It's so much easier to solve. So plus ln of x plus ln of x. So 4 is equal to ln of x. Let's back up just a little bit. I'm almost done here. Let's finish the problem. Okay. So now to get x to itself, what do we introduce? Yeah, e. Alright, e on both sides, e to the 4. So x is equal to e to the 4, but we're not looking for x, we're looking for k. I already know what k is. K is equal to 4 over the square root of x. So k is equal to 4 over the square root of e to the 4. What's the square root of, what is the square root of a to the fourth. It's a squared, isn't it? It's like saying a to the fourth raised to the 1/2, and 1/2 of 4 is 2. That would be a squared. So that's what we have here. But it's not a we're looking at, we're looking at e, aren't we? So now this k is equal to 4 over e squared, and that's a number, guys. Ladies and gentlemen, that's a number. E to the second power. E is not a variable, it's a number. And so we have a number. We have found the numerical value of k right here. You do not have to punch it in your calculator what that is. Just leave it like that. Could we have gone back over here and instead of solving for k, we could have very easily solved for x, substituted that in here, right here in place of x, and we would have found this either way. I don't know. It depends on your taste, if you will, of what you would like to do. I did it both ways. I actually did it both ways. So if you solved for x, you would have gotten 16 over x squared. And when you substituted that into f right there, you would have gotten the square root of 16 over e to the fourth, which is 4 over e to the second power. So either way would have been just fine. Alright, so and that would have been the conventional way. That's actually the way I did it the first time. But I got to study in different ways. Okay, could we solve for k and still get the same thing? Yes. And I think this turned out to be a little bit shorter than solving for x. Okay, solving for x took a little more time, a few more steps to get x by itself. But that's okay. Either way you want to do it, it's fine. But this is really nice. It's a cool problem. It's really nice, and it kind of keeps your solving skills intact up here. That's what it's kind of like exercising. I exercise. It doesn't look like it, but I do exercise 3 to 4 days a week, and you know, when you miss exercise, it shows, especially if you're lifting weights or whatever you're doing, or trying to jog. And I do jog a little bit, but I can't jog far. But still, anyway, if you quit exercising, believe me, it will show when you do try to do this again. And so this kind of keeps your mind really sharp. I like doing problems like this, and there are problems like this on the exam that you have to think about. But the key to understanding this problem are two things. Point of inflection. Oh, f double prime needs to be 0. You know that. X, it's on the x-axis. F is equal to 0. The y value is 0. Okay? And so once you do that, it's really, really simple there. You start off with f double prime, you know, and so k, for that point of inflection to be on the x-axis, k has to be this. But you know, you have to plug stuff, you know. Again, we could have solved for x. Either way would have been just fine. But solving for k, plugging it back in, I saw that it was real easy for this to divide out. And you could divide out because x is greater than 0. That was given at the beginning. Okay, and then now you can just easily solve. You're not done yet, because remember, you're looking for k. You already found out what k is from f double prime. Now plug that in here and you come up with this. And that's it. A very cool problem. I really like this. again, just they're testing your solving skills. That's really what this is all about, is testing your problem solving skills. Well, that's it for today. I'm going to look at some other videos, probably looking at 2008, 2009, and so on like that, and probably trying to find some problems from those. I keep a binder of everything that I have, all the different tests that I have done. That way I won't overlap something. But there again, even if I showed it again, we would need it, I'm sure. Your test is probably coming up if you haven't taken that already. I want to say that y'all do take that test in May. Again, who am I to know anything? I've been retired now, and I haven't been in calculus for a few years now. But anyway, I still know the ins and outs of this part. I can show you some things here, and if you're just a regular calculus student, this is going to help you as well. Sharpen your skills. It sharpens mine too. But anyway, KP the Math G signing off. Please don't forget to subscribe if you haven't already. Be nice if you did that. If you don't, well, okay, I understand. You just want to learn this, but subscribe if you want to. Leave a comment if you want to. Hit the like button, please. That would be, I like those. I really like those, and it puts a really big smile on my face. Again, I appreciate every one of you. I've been really busy working in the yard this week, and so I get a little time to do this. This is what I do. KP the Math G signing off. Ladies and gentlemen, have a great day.